The rafters with a ridge beam has to be built on site. So it requires a beam that's got to go from one end of the roof to another. So that's going to be a fairly large expense. The rafters are usually 2 by 10s or 2 by 12s. They might be 2 by 8s, but less likely. That beam is going to be a 4 by. It's probably going to be a glue laminated beam, because they are created out of smaller pieces, and so you can get really long lengths when you have a glue lam, as opposed to just trying to get a giant beam that's quite long and straight out of a tree. Um, they transfer load to both the beam and the exterior walls, and this is one of the most expensive ways of building a roof. However, 100% vaulted ceiling is possible, and a really nice attic space is possible. Or if you're building a house that's more of a what they call a 1.5 story, where you have dormers on the second story to give it a little more headroom, the beam is going to give you all that headroom that you're looking for. So because the beam is taking some of the load, that also means that the gable ends have a load-bearing component, whereas, as we see here in this little bit of math, so the loads, half of the roof load is going on the ridge beam, which then is taken up by the two gable sides. 1/4 is going to one exterior wall, 1/4 is going to the other exterior wall, where the rafters come and sit on the wall, and then the other 2/4 are at the gable ends. This is looking at some rafters with the ridge beam. It's a little bit of an unusual circumstance to see them done like this, where the ridge beam is located underneath the rafters. But what I want you to pay attention to is how wide the beam is compared to what we see of the underside of the rafters. That's the main way that you can tell if it's a beam or if it is a board. Boards are 2 by material, beams are larger. So as soon as we get past a 2 by to a 4 by, which is the next size, then it becomes a beam. And beams are always structural, whereas boards usually are not. Unless they're rafters, in which case they are. Here is a more typical sort of situation where we're seeing quite a large beam in this case. And this is an engineered beam. It is made up of a lot of small pieces of wood that have been glued together and formed under high pressure, a parallelogram beam. And it is even with the rafters, and these are solid sawn rafters. Rafters can be made with TJIs, but it's a little less common. And to note on this is the rafter connectors. So pieces of metal that are similar to the joist hangers that we saw last week with our floors. Rafters with ridge boards, you may or may not even see the ridge board. And I have to tell you, this is actually from a project that I worked on in, I always forget if it was Eastmoreland or Westmoreland, over by Reed College, where the rafters had such a small piece in between where they met that it doesn't even really show up in this image. And we were doing some renovations to this house. It was owned by a friend of mine, and so we took this photo afterwards because it also didn't have any collar ties, and you have to have collar ties if you have a ridge board because it is a code requirement, and also because what you see happening with these rafters is they're starting, gravity was taking hold and the rafters were starting to separate from one another at the top, and the roof was kind of flattening a little bit. The collar tie helps tie them all together, and it has to do, the reason this happens is because it's not being supported by a ridge beam, a structural large ridge beam. So rafters with ridge boards are also built on site. They're also going to have our rafters that are going to be 2x10s. They might be 2x12s. They could be 2x8s, but not usually. There's going to be a ridge board. Usually the ridge board is the same size as the rafters, although it could be smaller. And then, as I mentioned, there needs to be collar ties. Those collar ties are a third of the way down from the ridge or peak of the roof, and the code lays out how often they have to happen. I think we had to put some extras in here because we were adding a new roof on to the left side of this image that we see here. We were doing an addition, and so we have a new roof that is sitting on part of it. So we've got extra collar ties in that area. The rafters with ridge board are only putting load on the walls where the bottom of the rafters land. So my gable ends don't have any load on them from the roof, and it is a medium cost. The materials are fairly inexpensive, but there's a lot more labor involved in it. Here's another look at collar ties and what's happening with the ridge board. So we see the ridge board, the rafters are going up and are toe nailed, so nailed at a diagonal through. And we also see that the bottom of the rafter is the term for the shape that's made where it meets the double top plate of the wall is a bird's mouth. And so there's a notch taken out of the rafter so that it makes really good contact with the top of the wall so that those rafters are really sitting nicely on there. Now with a truss, we don't have to do that because the truss has a bottom to it that is that bottom cord that makes the ceiling setup. So it's only going to be rafters that have the bird's mouth in them. And in this case, we're actually seeing two collar ties with bolts on either side. It can be one single one, or they can be doubled up like this. And lastly, we have SIPs. So as you see, this is made of 4 pieces. This particular roof, as I mentioned earlier, it's got a skylight cut into it, and it's got quite a large beam because this is a gabled roof that slopes in 2 directions. And that beam has a notch cut into the gable end, the triangular piece that creates the wall, that makes so that that beam has a really good place to sit, very structurally sound. And most likely that is a glue lamb beam, if I had to guess. As mentioned before, it creates a very airtight building envelope and roof as the seams are all taped. It has a very high R value. They are expensive roofs for the materials, and also that beam would be expensive. Ideally, it is a sloped roof, and SIPs really needs to be installed during dry conditions. If you've followed any of the stories of the Newberg Center, PCC Newberg Center was built with a SIPs roof, and unfortunately it was a fairly new material when the roof went in, and a low sloped roof, and the people who did the installation didn't really understand all the parameters. The roof got wet before it was finished being installed, and water wasn't able to drain away, and it caused problems. Not once, but twice. It's been rebuilt. So it's got to be installed during dry conditions. It's extremely important for the roof. And again, flat roof might have more problems than a roof that has some slope to it. So, thank you for listening, and I'll see you next time.